Welcome to the DIY Honda Garage channel. DTC P0135 indicates a malfunction in the air-fuel, or AF, sensor's heater circuit. The AF Sensor 1 includes a built-in heater to ensure optimal operational temperature, which is vital for accurate readings of the air-fuel ratio. This sensor is located in the exhaust system, typically upstream of the catalytic converter. Its proper functioning is crucial for the vehicle's fuel management and emission control systems. When a heater circuit failure is detected, it can lead to poor engine performance and increased emissions. In addition, it often triggers the check engine light, alerting the driver to potential issues that could affect driving efficiency and safety. DTC P0135 specifically refers to a failure in the heater circuit of the air-fuel AF Sensor 1. This sensor is critical as it measures the air-fuel mixture in the engine's exhaust gases before they pass through the catalytic converter. The AF sensor is typically located in the exhaust stream, allowing it to measure emissions directly. When the heater circuit malfunctions, it results in an inability for the sensor to reach operational temperature, which eventually leads to inaccurate readings. This has a cascading effect on the vehicle's fuel delivery system, which relies on precise data for optimal engine management. Therefore, identifying and resolving this issue is crucial for maintaining performance and compliance with emission standards. When diagnosed with DTC P0135, several potential causes can arise. One of the most common issues includes poor electrical connections, which can occur at the AF sensor or within the wiring harness. Corrosion, frayed wiring, or loose terminals might interrupt the proper signal flow, leading to a malfunction. Additionally, the AF sensor itself may be faulty, which typically requires replacement if verified through resistance checks. Another possible cause could involve shorted or open circuits within the wiring, specifically the lines leading to and from the sensor. Each potential cause must be investigated thoroughly to ensure an accurate diagnosis and effective repair. Symptoms of DTC P0135 may manifest as a check engine light activation, signaling a malfunction that requires attention. Drivers may also experience poor fuel efficiency because an inability to accurately measure the air-fuel ratio can disrupt optimal combustion, leading to wasted fuel. Additionally, a rough engine idle might be observed, as the engine struggles to maintain an efficient air-fuel mixture under various operational conditions. These symptoms not only affect driving comfort, but may also lead to increased emissions that can violate environmental standards. It's important to address these symptoms promptly to restore the vehicle's performance. The first step in troubleshooting DTC P0135 involves verifying the problem through the vehicle's diagnostic system. Begin by turning the vehicle to the on mode without starting the engine. Use the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. Following this, start the engine and hold the RPM at 3000 without load, ensuring the continuously variable transmission, CVT, is in park or neutral. This step allows the engine to run at high RPM, ultimately prompting the radiator fan to engage, which serves as an indicator of proper operation. After the fan activates, let the engine idle and then check for any pending or confirmed DTCs. This approach ascertains whether the DTC is persistent or intermittent, guiding the next steps in the troubleshooting process. In Step 2 of the troubleshooting process, you'll again check for pending or confirmed DTCs using the HDS. Specifically, pay attention to potential alternate codes such as P1688 or P1659, which indicate issues with the electronic throttle control system, ETCS relays. If these DTCs are present, follow their specific troubleshooting procedures to address the associated failures. If no additional trouble codes are found, proceed to step 3, as this could indicate an intermittent failure. Always document any observed DTCs, as they can guide diagnostics and future troubleshooting processes effectively. For this step, you'll begin by turning the vehicle to the off mode to safely check the fuse. Locate fuse number A37, which is connected to the AF sensor's heater circuit. Using a multimeter, verify if the fuse is intact. If the fuse is blown, this could indicate a short or overload condition. Should you find that the fuse is defective, repair any shorts in the IGPS lambda air fuel wire that connects to the AF sensor and replace fuse number A37. This step is critical as the fuse serves as an essential safety measure, and any underlying issues in the wiring could lead to recurring faults if not addressed. In this step, you will disconnect the AF sensor 6P connector to access the internal circuitry of the sensor. Once disconnected, measure the internal resistance between specific terminals, number 2 and number 3 on the male side of the 6P connector. Utilize a multimeter to ascertain if the resistance falls within the specified range of 2.8 to 4.5 ohms at room temperature. If the resistance meets these specifications, it indicates that the sensor's internal heater is functioning correctly. However, if the resistance is outside this range, you will need to replace the AF sensor, as a failure in this component will directly contribute to the DTC P0135. Step 5 involves checking the continuity of the A field sensor's internal circuit with respect to the vehicle's body ground. Disconnect the A field sensor 6P connector to perform this test. You will need to measure continuity between each terminal of the sensor, specifically terminals 2, 3, 4, 5, and 6, and the ground individually. Establishing continuity indicates that the circuit is intact and functioning as intended. Should you find a lack of continuity at any point, replace the A field sensor, as this signifies a fault within the sensor's internal circuitry that could compromise its functionality. In the 6th troubleshooting step, check continuity between additional sensor terminals and the AF sensor 6P connector number 3. Ensure the vehicle is in off mode and the connector is disconnected for safety. Performing this test confirms whether there is an open circuit that could lead to DTC P0135. Measure continuity specifically for terminals 4, 5, and 6, relative to the sensor side's reference point. If continuity is present, progress to step 7. However, if continuity fails to register, it is necessary to replace the AF sensor, as an issue in this circuit indicates a substantial fault that could impair measurement accuracy. Step 7 involves checking for a shorted wire in the AFHT-N line. Begin by jumping the SCS, service check signal line, using the HDS, and waiting for more than a minute to ensure a stable reading. After this, disconnect the PCM, Powertrain Control Module Connector E, specifically the 80P connector, and then test for continuity between test points 1 and 2. Point 1 is identified as PCM connector E number 13, and point 2 is a body ground. If continuity is detected, this indicates a fault in the AFHT-N wire, necessitating repairs from the PCM to the AF sensor wiring. If no continuity is observed, proceed to step 8 to further investigate the wiring condition. In the 8th troubleshooting step, you will again check continuity, this time between 2 critical test points to confirm circuit integrity. With both the AF sensor 6P connector and PCM connector E, 80P, disconnected, test the points. Female terminal number 2 at the AF sensor side and number 13 at the PCM side. This test checks for an open circuit in the wiring that could impair sensor operation. If continuity is present, this indicates the wiring is intact, and you can move on to step 9. Conversely, if there's no continuity, repair any opens in the AF-HTN wire between the PCM and the AF sensor to restore proper function. Finally, in step 9, begin by turning the vehicle to the on position to enable power to the circuits. Then, measure the voltage between test points involving female terminal number 3 of the AF sensor 6P connector and a solid body ground. This test checks the integrity of the IGPS, lambda air-fuel line, for proper voltage. If you find you have battery voltage, the line is functioning correctly. At this point, if further issues persist, inspect any authorized service information relating to the DTC or consider substituting a known good PCM, powertrain control module, for further validation. However, if no battery voltage is detected, repair any open circuits in the IGPS line between the AF sensor and fuse number A37 to rectify the situation. Upon completion of the repairs related to DTC P0135, it's essential to perform a final verification process. Begin by clearing any DTCs from the vehicle's diagnostic system using the HDS. After clearing, conduct a comprehensive test drive under various operational conditions to ensure the repair has been successful and no new DTCs emerge. Monitor the vehicle for any reoccurrence of the check engine light or related symptoms to confirm that the issue has been entirely resolved. If everything operates smoothly without triggering additional codes, you can be confident that the repair was successful and the vehicle is back to optimal performance. To proactively prevent issues related to DTC P0135 and ensure the longevity of the AF sensor, implementing a routine preventive maintenance schedule is crucial. Regularly inspect the integrity of sensor connections and wiring harnesses for signs of wear, such as fraying or corrosion. Ensure connections are clean and free of moisture to mitigate failure risks. It's also advisable to replace aging sensors that may begin to underperform, as they can lead to inaccurate readings and ultimately complicate the engine management system. Regular checks help minimize unexpected failures and costly repairs, promoting optimal vehicle performance and compliance with emissions standards. In summary, DTC P0135 highlights a significant issue with the A-factor sensor 1's heater circuit, emphasizing the importance of accurate diagnostics. Detailed troubleshooting steps systematically guide technicians in identifying and resolving the underlying problems. It is vital to carefully check connections, wiring, and overall sensor functionality to rectify the issue effectively. Regular preventive maintenance plays a key role in minimizing the recurrence of such faults. By maintaining vigilance on sensor health and connections, drivers can ensure optimal fuel efficiency, performance, and compliance with environmental requirements. Understanding this DTC and its implications allows for well-informed and timely repairs. Please like and subscribe to the channel. See you next time.